In section 7.2, we're going to be looking at three different types of chemical reactions: precipitation reactions, acid-base reactions, and redox reactions, which are oxidation-reduction reactions. Our first type of reaction is precipitation reactions. In a precipitation reaction, we have some aqueous solutions that get mixed together, and in the end, a solid product gets formed. That solid product is going to be called the precipitate. Most precipitation reactions are going to be what we call double replacement reactions. These may also be called double displacement reactions or metathesis reactions. In a double replacement reaction, the ions are going to switch partners. I like to think of this as if you went to a dance with a partner, and your friend also went to that same dance with a partner, and when you got there, you both realized you liked the other person's partner better. Your partner wanted to be with your friend, and your friend's partner wanted to be with you. Everyone agreed to changing partners, so you did. You went home with your friend's partner, and your friend went home with your partner. The same thing happens here with the ions. They go home with a different partner than they came with. It's still always going to be a positive ion with a negative ion. So positive is not going to go with positive, and negative is not going to go with negative, but they're switching partners. In this example, the calcium comes in with the chlorine, but it leaves with the nitrate, and the silver comes in with the nitrate, but leaves with the chlorine. With double replacement reactions, we have them switch partners, and as we predict our products, we have to make sure that we're making neutral ionic compounds with zero overall charge. Don't worry about how many chlorines you started with or how many nitrates you started with. We can balance the equation later. What's important here is making neutral ionic compounds. Use your crisscross rule the same as you would when you're identifying the formula of an ionic compound. If we have calcium ions which have a +2 charge and nitrate ions which have a -1 charge, we crisscross them. The 2 from the calcium goes next to the nitrate, and the 1 from the nitrate goes down next to the calcium. First, we make sure our ionic compounds are neutral overall. Then we can worry about balancing the reaction after we know our products. In this case, we balance it by putting a 2 in front of the silver nitrate and a 2 in front of the silver chloride. It doesn't matter that we had 2 chlorines on the left in the calcium chloride, but silver chloride only ended up with 1 chlorine in it, because we put a coefficient in that fixes the problem. As we're writing our reaction equations, we're going to include states of matter. The states of matter for compounds on the left will be told to us, and usually they're going to be aqueous. One of the compounds on the right will be the precipitate, that is, the solid product. We need to be able to predict which of the two substances on the right side of the reaction will be that solid product. In order to do that, we have a list of solubility rules to help us remember which compounds are soluble in water and which compounds are not soluble in water. Substances that are soluble in water get the AQ symbol next to them. They will be aqueous, dissolved in water. Substances that are not soluble, that is, if they are insoluble, get the S symbol next to them, S meaning solid. Remember, S stands for solid, not soluble. Here's a list of some ions that are always soluble. I want you to memorize this list. The group 1 metal cations are always going to be soluble: lithium, sodium, potassium, rubidium, and cesium. Any compound containing an element from group 1A, no matter what it's bonded with, that compound will always be soluble in water. The ammonium ion, which also happens to have a +1 charge, is also going to be soluble no matter what it's paired with. For example, ammonium chloride, ammonium nitrate, and ammonium hydroxide are all soluble in water. It doesn't matter what the ammonium is paired with. If it's got ammonium in it, then it's soluble. For negative ions that are always soluble, we have a few polyatomic ions. There's acetate, bicarbonate, nitrate, and chlorate. If it has any of those 4 polyatomic ions in it, it will be soluble no matter what it's paired with. For example, calcium acetate, lead acetate, and iron acetate are all soluble in water. It doesn't matter what the acetate is paired with. If it's got acetate in it, then it's always soluble. On the next list are ions that are generally soluble. The halide ions from group 7A, chloride, bromide, and iodide, are generally soluble except when they are paired with the silver 1 ion, the mercury 1 ion, which is Hg2 2+, or the lead 2 ion. For example, sodium chloride and calcium bromide are both soluble in water. Silver iodide would not be soluble because silver is one of the exceptions to the rule that halides are generally soluble. The fluoride ion gets its own category even though it is also a halide, because it has some different exceptions. Fluoride is also generally soluble, but its exceptions are going to be the group 2A metals like calcium or barium, along with lead 2 and iron 3. If fluorine's with any of those exceptions, it will not be soluble. If it's paired with other things that are not the exceptions, it will be soluble. The sulfate ion is generally soluble except when it's with silver, mercury, and lead, calcium, strontium, and barium. Remember, silver, mercury, and lead are also exceptions for the halide ions, and calcium, strontium, and barium are also exceptions for the fluoride ion. Notice that the sulfate ion is the only one that has a +2 charge that's generally soluble. All of the other ions that are either always soluble or generally soluble have either a +1 or a -1. Generally, the higher the charge, the less likely it is to be soluble. Finally, here are some compounds that are generally not soluble in water. The carbonate ion, chromate ion, phosphate ion, and sulfide ion are generally not soluble unless they are with group 1A ions or the ammonium ion. Remember, these are the ions that we already know will always be soluble. If one of these 4 ions is not with one of those that's always soluble, then we're going to assume that it's insoluble, that is, not soluble in water. The hydroxide ion, which has -1 charge, is also usually not soluble. But if it's with one of the cations that's always soluble, or the barium 2+ ion, then it will be soluble. For the ones that are generally soluble or generally insoluble, I will provide the table for you, and you will just need to interpret it. But for the ones that are always soluble, you need to memorize those. Which of the following is water soluble? Is it A, barium sulfate, B, silver hydroxide, C, lithium hydroxide, or D, calcium carbonate? The correct answer is C, lithium hydroxide. The lithium part of it makes it soluble in water. Remember, if it's got an ion from group 1A or the ammonium ion, it's always going to be soluble.